Well, there's a lot going on in this lecture. We're going to discuss how chain reactions are set in motion. In particular, we'll discuss the fissioning of U-235. There's a neutron. You may recall that was liberated once the shell surrounding the beryllium in the polonium sphere is broken. A neutron strikes a U-235 nucleus, causes it to break apart and liberate two more neutrons. And then each one of those two go on to give rise to two more. And those two do the same. And so you start with one neutron in. That's the first generation of growth of neutrons. One fission will have taken place. Then two fissions in the second generation, 4 in the third generation, 8 in the fourth generation. The total number of fissions that have taken place based on the generation number is shown here. After the first generation, only one fission has taken place. Then after the second, a total of 1 plus 2 more, a total of 3. Third generation, the original 1 plus a 2 plus 4 more gives 7. And then in the fourth generation, a total of 8 plus 4 is 12, makes 14, total 15. The equation which allows you to predict how many fissions will have taken place is shown here. Let S be the sum of all of the fissions that occurred in the various first, second, and third, and fourth, and so on generation. You can check to see that this equation will reproduce these numbers if we let the so-called neutron multiplication factor, let's call it K, be 2. The neutron multiplication factor K is the number of offspring each neutron gives birth to. In this case, this example, it's 2. And so we have this important equation that can be put to use to calculate how many fissions will have taken place after one generation, 2, 3, 4, 20, 100. Given also that the time it takes between consecutive parents, grandparents to parents to grandparents and so on, is this very small number here, 10 to the negative 18 seconds, which by the way is 1 attosecond. If we know how many generations are going to go by, we could calculate how many seconds it will have taken for that many generations to have been born. Let's consider this. The Hiroshima bomb had an explosive energy of 16,000 tons equivalent of TNT, dynamite. Imagine that. An automobile has a weight of a ton. Imagine that much in dynamite. And then imagine 16,000 of those equivalent TNT. And let that go off 2,000 feet above the city of Hiroshima. No wonder such devastation occurred. Well, let's calculate how many generations will need to have gone by in the atomic bomb chain reaction in order to create this amount of energy. Each fission, we saw in an earlier lecture, maybe we did or did not, but the energy released in one fission reaction is this number there, 1.9810 to the negative 11. Divide the two to get the total number of fissions that need to have occurred. We have this large number here. Now the question we ask is, how many generations will have to have occurred? And so we have S sub n equal this number here, but S sub n is this equation, where K we'll assume is 2. solving this equation for n, we get about 82 generations need to have occurred, which means that it's all over in this many attoseconds times 82, not even the blink of an eye. It'd take longer for this amount of energy to be generated if the neutron multiplication factor were 1.3. Substituting 1.3 into this equation for k, and we get n more than 211 generations will need to have occurred. 211 attoseconds it would take. Now, this neutron multiplication number calls to mind the infection rate of the coronavirus. In the beginning, it was thought that each newly infected person infected 2.3 more in just 2 days because of their interactions with friends and family and co-workers. And so suppose we start with that one infected person who goes about his or her business and meets people at the grocery store, at work, on the street, at home, and that every 2 days another generation of infected persons is created at the rate of 2.3 per person. Suppose we let it go for 30 days, do nothing to mitigate the infections. 30 days is 15 generations. Divide 2 into 30. So now take the same equation shown here with k equal to 2.3, and we have, after 30 days, there will have occurred, because of just one person, 116,000 infected persons were born because of that one person's interaction with people day to day. I hope you've learned something from this.